Hello. Now our next challenge is and JavaScript Kiddie 1. JavaScript Kiddie. So let's open the challenge. We are given the search box. Let's enter something. Number here. Search. We got a broken image like something. Let me once more. There it is. So let's look at the code and sources. Okay, here's the code. So basically what is this doing is, and it is getting some bytes from bytes page. Let me search for a bytes page. Yes, here it is. Here are the bytes that we are getting. Then it is splitting it with fork, and basically it is making an array of bytes that we have shown previously, and we have a function assemble png which is taking a key of 16 length that we are submitting by here, and there is a where shifter, and if the key length is 16, the key is changed with a one entered key. Then we have make a result variable, then we do some manipulation on it, like something we are taking for every we are iterating over our key and taking our key character, each character, and then we are iterating over our bytes.length by length j++. It is bytes. We can check the length of bytes from here. Bytes dot length, that is 720. So it is taking by bytes dot length, that is 720 divided by 16, which is like 720 divided by 16, it is 45 times. Okay, so this is iterating over 45 times, with result is equal to j into length plus I is equal to bytes into the bytes array, something like this. So basically we have to reverse this. I have written a script which we can use. Let me show. So now we are back, like this is our script that we can use to check for the password. And since there is another method, something like using a brute forcing method, which is not feasible as much, because it is a length 16, and if we brute force the password, it will take us into 2 to the power 16 combinations, which is not feasible to check out. So we have written so we have to get something to brute for to get what we can say, something like to reduce the number of combinations, so we can check it out. So first and that we get is image is png type. It is written here, data image png. So here is the hint that we have png image, and we can check any png image that has a header file. So the png header, we can say signature, which every png file has constant. Let me show ghex some profile. Like this. So it is a png header like this, and I think it is 16 bytes. 3 4 5 6 7 8 9. Okay, these 16 bytes are constant in every PNG file, so we can use this to get our PNG file. So by reversing this function, so let me show the script to reverse this. So these are the bits that are constant in a PNG file. Like here we can see this, it is and 52. These are the bytes. So what we do is we are getting each byte, checking the number of times this byte is occurred in this array, then created a docker key, that is our key basically. This is multiple blocks if the number of times that it is repeated multiple. So now let's check if this is this is our variables. Now iterate over the PNG header one by one and check it out. So these are the bit, like what is the PNG header that we are on, that the byte we are checking, byte count, the occurrence, number of occurrence in this, byte index, in which index we are at, means at what index it is occurring in this array, then valid blocks, number of blocks that is valid that we can take as a key, means if let's take an example, like 159 is coming here and 159 is coming here also. So means if this 159 and this 159 is valid to take in our key, we will see earlier more precisely, like, and then it is checking for the valid, it is valid or not. If it is valid, it is taking it into multiple blocks, or invalid, that it's simply ignoring it. Then iterating over next and next and next and completing over the full array of this. So now, and then we can, it is like increasing the byte. Okay, so this is our generating key function, that is that generates all the key combinations with the possible number of keys that we have find it here only. So this generates the key combinations and stores into a variable key. Then for each key we are using document.write, that is our shown, and assemble PNG function, that is from assemble PNG functions, that is from the original function of the that is the original function that we are given with. So this is the same function. So let's try to run this script in our web browser, like let me go to the, it is challenges and picoCTF web, that is. So on running the script, if you find this, let me check the inspect console. So this is given our this give more than one valid blocks for 0 at 8 with count of 3. It means the position of the byte 0, which is at position 8. We have 3 position blocks, means we have 3 blocks which have byte 0, means we have 3 position in this array for the 0 byte, which can be valid. And same for this with 4, and same for this with 3. So this gives a total of 3 into 3 into 4, that is 24 combinations. On scanning this QR that we are given here, we get our flag, that is let me get the flag here. There it is. We get the flag, which is this. We can use any online or maybe use camera to scan the QR, and we will get this flag here. let me submit the flag. Okay, now the next JavaScript Kiddie, so surprisingly it also works on the same script. Let me show you. First go to inspect, and then it is a little change in this, like something, the key length is 32 bits, but due to its configuration in shifter value, it takes only the second key, like it takes the first bit, then it takes the third bit, then it takes the fifth bit, and so on. So it takes every second bit as it so basically the key length is 32, but our key actually is of length 16, since it takes only second byte. And there is no difference in the encryption, and just these two differences, shifter and key. The shifter cancel out the effect of key, so we can use our same same script to get our flag. So let's change the bytes with the new bytes of this function, save this, and refresh this. So here we have got with 2 into 2 4 total combinations with one of the flag with a QR, and on scanning the QR we get our flag like this. I am not scanning the flag here since we can already scan this. So it is the picoCTF and JavaScript Kiddie. Submit this. Okay, done. Thank you.